Good morning and welcome. Good afternoon or good evening, depending on where you are in the world. I'd like to present a new series on my software testing journey. I'm going to start with my learning of the series all the way to me starting to work in the industry. So, before I start, I would like to let you know this is for educational, informational, and review purposes. It's not to take the credit for the intellectual property. Right here it says copyright at tutorialspoint.com. Okay. And if I scroll down the full text, it's as if that's the whole thing. Okay, I'm gonna go lesson by lesson. This is actually from a course, a Udemy course. I'm gonna do a different spin on this one. I'm gonna see my journey. It also says here http www.software_development/software_life.cycle.ht. So that website and this copyright, or at least this copyright itself, gets the full credit for the intellectual property. Okay? My purpose is not to take the credit for this work that was already been published and or made. The purpose here is to just show my journey. I'm just going to use something that's already in course and just to educate people about it, but to make sure that the person copyright at tutorialspoint.com gets the full credit for intellectual property. All I'm using is something that's in the public domain. It was in a public course on Udemy, and I'm just showing you my journey to becoming a software tester, more specifically manual QA, which is quality assurance. So basically, there's three levels, and this is kind of my introduction. Um, there's three. Basically, there's three levels. There's manual QA, which is manual quality assurance. Okay. Then there's automated, which is basically programming to do the same task as the software tester who does this manually. And then there's something called developer operations, which is basically people who test out and test all the software on all the programs that you have, programs, websites, etc. And they work in a team to check the software itself. So we go from checking like the software for bugs in a manual way versus writing a program that does it to looking at all the programs themselves on a deeper coding. We're not so much focused on coding as we are looking at the software testing management area. So you basically have two things. You have something called Scrum, and you have something called Agile. Now, Agile is a type of software that's used for software testing. Now, software testing can be any type of software. It can be anything from games to applicate any kind of application itself. Now, I want to start with chapter one, which is this is basically the backbone and base of it. It's called the software development lifecycle. Software development lifecycle, or SDLC for short, is a well-defined, structured sequence of stages in the software's engineering to develop the intended software product. Basically, think of project management, but just for software. Now, let's talk about the SDLC activities. And by the way, I plan on putting this out 5 to 6 days a week. Okay? So, SDLC provides a series of steps to be followed to design and develop software productivity efficiently. SDLC framework includes the following steps. We have communication, requirement gathering, feasibility study, system analysis, software design, coding, testing, integration, implementation, operation, and maintenance and disposition. So let's do that one at a time. Now this is just part of the software development lifecycle. I'm just going to do one of those a day, 5 or 6 days a week. There's an attached documentation. recommend you read more in depth about this, but basically this is what this is, okay? In terms of communication, this is the first step where the user initiates a request for desired software product. He contacts the service provider and tries to negotiate the terms. He submits a request for service and providing organization in writing. Second of all, a requirement gathering. This step onwards, the software development team works to carry on the project. The team holds discussions with various stakeholders from problem domain and tries to bring out as much information as possible on the requirements. Requirements are contemplated and segregated into user requirements. Contemplated, which is thought out, and separated, segregated into user requirements, system requirements, and functional requirements. So let's break that down for a moment. So the requirements for this. Um, okay, so think first of all they're thought through. They're separated into user requirements. Does the user expect? And then the system requirements. So you have the user who's using it, you have the system itself, and then you have the function, meaning what should it actually do. Requirements are collected by using a number of practices given. Number one. Actually, you know what I'm going to do is I'm going to highlight this, guys, because I'm going to be putting this on my Instagram for people who want to study this. I will make sure that I give full credit to the person who created this, and full credit to the intellectual property. But this is not secret. This is common knowledge about SDLC. Just the document itself written down is copyright of them. So anyway, the first step where the user initiates a request is for desired software products. He contacts the service provider and tries to negotiate the terms. He submits the request to the service provider organization. Now, that's for communication. In terms of requirement gathering, this step onwards, the software development. This step onwards, the software development team works to carry out projects. So this is kind of like the project management aspect. The team holds discussions with various stakeholders from problem domain and tries to bring out as much information as possible on the requirements. Um, when we talk about the software development lifecycle, we talk about different aspects and different roles. Okay, we talk about the tester, that's one, and after the tester, we talk about the Scrum Master, which is basically another word for manager. Another word for project manager. I recommend you guys study project management because it relates to this, and I will be putting out a course on project management. Okay, so actually, it's quite a bit of work for me to type it out because I haven't found a good solution for scanning and having it come out as text. I'll be looking into it, but for now, I don't have a good solution for that. So the requirements are contemplated and segregated into user requirements, system requirements, and functional requirements. So basically, if we think about the software, we think about how it's managed and how it's developed. Well, you have a software development team, and we have a management team. So we need people from different roles. We have the software testers at the bottom. The software testers is multi-tiered, so that's one major level. So that major level, you have basically two tiers within the major level. You have the manual QA and you have the automated QA. And then above that, the next tier would be the DevOps, which is probably, I take it, That's the next level, which is the developers, otherwise known as the programmers. I take it that's two parts or two tiers of the same team, kind of like offense and defense. DevOps is more defense, and developers themselves is more offense. If you want to think in terms of a sports analogy, then after that you have the Scrum Master, which is basically the project manager. Then you have owner, which is the owner of the project, the owner of the team, or whatever it is. That's the Scrum, and that's the owner. So you have different levels. I'll talk more about that in the future, but those are some basic. I think there's another one or two steps in between from owner to the Scrum Master, but basically that's the idea. Now, requirements are collected using a number of practices. As the number one, we're studying the existing or obsolete system and software. Number two, we're conducting interviews of users and developers. Number three, referring the database. Number four, we're collecting answers from the questionnaires. Remember, we're trying to figure out the requirements, both functional, system, and user requirements. Remember something, we're creating this software for the purpose of the end user. So we need to understand the end users. We need to understand the system that we're running under, which is basically the software itself that's running it. And we need to compare it to the functions that it's supposed to be able to do. Okay, that's what we're actually testing the functions, but it's from the point of view of the user and also in the environment of the system. Just like, for example, as productivity software is out on the platform, which is the environment, for example, Windows, Mac OS, finally microsystems, etc. Now remember, these number of practices requires four things, as I mentioned. We need to study the existing system, existing or obsolete. Obsolete means out of date. Existing system or obsolete system. Basically, we want to figure out what system are we using, and then we need to figure out the software that we're using, this function. Then we need to interview the users and developers to see what are the users, what is the user's perspective in terms of their functionality, and developers, how is this made from all 3 points of view. Also, we need to refer to the database where we can log our observations. Later on, we'll talk about common software errors, but for now, that's what we have. And then finally, we need to collect the answers from the questionnaires. We'll have some questionnaires. This is basically like the result, or this is the format of how we get the format of the software testing itself and the answers. And then from the questionnaire, which is the format for collecting the answers, and then we put it into the database where we can see all the different errors, etc. Now let's talk about the feasibility study. Now, after requirement gathering, the team comes up with a rough plan for the software process. Okay, meaning it's A, B, like a step-by-step process. At this step, team analyzes the software can be made to fulfill all requirements of the users. What is the user? What does the user want it to do? And if there is any possibility the software brings no more useful, it is found out the project is financially, practically, and technologically feasible. Take up. There are many algorithms available which help the developers conclude the feasibility of a software project. Okay, this is a very abbreviated version of what it actually is. This is actually quite sophisticated. As far as system analysis, at this step, developers decide a roadmap of their plan and try to bring up the best software model suitable to the project. System analysis includes understanding of the software product limitations. What can it do? What can't it do? It's learning system, related problems, or changes to be done in existing systems. That is, beforehand identifying and addressing impact of projects on an organization and personnel, etc. The project team analyzes the scope of the project and plans and schedules resources accordingly. Remember, this is done beforehand and identifies and addressing the impact of the project organization and personnel, etc. Now, in terms of software design, the next step is to bring down the whole knowledge of requirements and analysis on the desk and design of the software project, a product. Inputs from users and information gathering phase, and the inputs in the step. Okay? So we have inputs from users. That is information gathered from requirement from the requirement gathering phases to the input of the step. The output of the step comes from the form of two design. So we have input and output. If we really break this down, it's not that different. We need to see, is it fulfilling its purpose? We look at the inputs. We have a gathering stage for the inputs of the step. Then we look at the output of the step. Comes in the form of two designs. Number one, logical design. The second one is physical design. And logical would be the code. Physical design would be the interface, what you see. Okay? Engineers produce meta-design and data dictionaries, logical diagrams, data flow diagrams, in some cases pseudocodes. Okay, so we can see the visual representation, which is the physical design. That's the physical design. Logical design would be the pseudocodes. See that? Now, in terms of coding, this step is also known as the programming phase. This makes complete sense because we're talking about coding. Implementation of software design starts in terms of writing programs in code and programming language, developing error-free executable programs that is efficient. In terms of testing, see, we're having all these things here. Okay? Testing. Estimate says that 50% of the software development process should be tested. Errors may ruin the software from critical level if it's unremovable. Software testing is done when coding by the developers and thorough testing is connected by testing experts at various levels of code. Okay, so that could be your developer ops, and well, that could be actually all three. That could be the manual QA, and I think the automated as well, depending on what they're doing. Definitely the manual QA and definitely the DevOps. DevOps would be sort of at the end to make sure that there's no software bugs. Just kind of but then larger, more complicated scale of DevOps. Now, in terms of integration, such as a module testing, we have module testing, program testing, product testing, and in-house testing and testing of the products at the user's end, which is basically what manual QA does. Early discovery of errors and the remedy is key to the reliable software. This is early discovery of errors. Meaning we want to discover it before it gets published. In terms of integration, software may need to be integrated with the libraries, databases, and other programs. The stage of the SDLC involved is the integration of software with outer world entities. And I will, with the the following chapters, I'll talk more about this process, but this is very much laying the groundwork. This is basically definition wise. In terms of implementation, this means installing the software on user machines. At times, software needs post-installation configuration. On the other end, software is tested for portability, adaptability, and integration-related issues solved during implementation. So basically, you install the program, what happens? That's integration. Integration is when you put software into libraries and databases. Implementation is okay. You put in the library's databases. Now we need to install it. Now once it's installed, we operate and maintain it through operation and maintenance. The phase confirm the software operation in terms of more efficiency and less errors. If required, the users are trained on and aided with documentation on how to operate the software and how to keep the software operation. So that could be anything from updates, tests, any number of things. Um, and following lectures, I'm going to talk more about the common software errors in terms of types. The total common ones is like hundreds of them, but when I talk about in the future, when I talk about categories of them, I talk about the most common ones first. The software is maintained timely by updating the code according to changes taking place in end user and environmental technology. The phase may face challenges from hidden bugs and real-world unidentified problems. So that's what the software tester is supposed to. Once it's ready to go, once it's published, we test it out. We also have a disposition. As time elapses, the software may decline in performance front. It may go completely obsolete or may need intense upgradation, basically upgrade. Hence, a pressing need to eliminate a major portion of the system arises. The system includes archiving data and required software components. Closing down the system, planning disposition activity, and terminating the system as appropriate end of system time. So it's just like product. Products have a life cycle, has a beginning and it has an end. From the beginning of it, the testing all the way to the implementation, release, and then it's used, and then once something better has come out as a major release, then the life cycle ends and you start all over. In terms of the software development paradigm, the software development paradigm helps developers to select a strategy to develop the software. A software development paradigm has its own set of tools, methods, and procedures which are expressly cleared and define software development of the life cycle. We're here in the context we're talking about life cycle. A few of software development paradigms or process models are defined as follows. Now let's talk about the software development idea as a whole. First, we're talking about the waterfall model. Notice how it's going down. Waterfall model is the simplest model of software development paradigm. It says all the phases of software development will function one after the other. So if you call it like a domino, in this case they call it a waterfall, whatever you want to call it. When the first phase is finished, only the second phase will start, and so on. So the next phase only starts when the previous phase ends. So first we start with requirement gathering, system analysis, coding, testing, implementation, and operations and maintenance. This is the waterfall model. Okay? The model assumes that everything is carried out and taking place perfectly as planned in the previous stage, and there's no need to think about past issues as they arrive in the next phase. This is sort of a theoretical best case scenario. The model does not work smoothly if there are some issues left in the previous step. The subsequential nature of the model does not allow us to go back or undo or redo any changes. So this is definitely not. Part of it's not ideal because it becomes a finalized process. But the idea is if it works perfectly, which I don't like the word perfect because perfect is relative to the time period and also true perfection doesn't exist among human beings. So we have the waterfall model, we have the iterative model. Model leads the software development process in iterations and projects process of development in a cyclical manner, resulting every step as a cycle of the SDLC process. If we look at the diagram, See, we have testing, we verify, we have design, we design the software, coding, then testing, then we verify. Go back to design, then we have coding. So how we have that? So in mathematical terms, is n minus 1 iteration of n is here. And then at the end, after we have it, we have the n plus whatever comes after, which is the coding itself. The coding is first developed on a very small scale, and then the steps are followed which are taken into consideration. Then on every single iteration, more features and modules are designed, included and tested and added to the software. Every cycle produces a software which completes itself and has more features and capabilities than the previous one, which makes sense. After each iteration, the management team can do work on risk management before for the next iteration. Because the life cycle includes a small portion of whole software processes, it's easier to manage the development process, but it consumes more resources. And here we have something called the spiral model. Excuse me. Spiral model is a combination of both the iterative and the SDLC model. It can be seen if you choose SDLC model to combine it with a cyclical process called iterative model. Now, with the iterative model, doing this, what we do is we start off, we go basically in a circle. We're going to start off with the objective identification, cumulative cost, then we progress to the alternate evaluation, which is risk management and prototypes, with design, code, integration, testing, implementation, similar to what we had before, and release. If you think about it, makes perfect sense. Just like if we're an assembly line, what do? We do everything step by step. Before we code, we need to design. Before we design something, we need to have an idea about what we want to design. And before we make a prototype, we have to assess the risk of it, okay, in terms of project and expressed in project management. So we design it, we code it, then we integrate it, we test it, and then we implement it. Then we have our release. Then we go to the next phase of it. We're going to do the same thing over and over and over again. You see? We're going to go back to review. The next planning phase is like step 2. We go to review, object identification, cumulative process, etc. Keep repeating the same step over and over and over and over and over until we get a final one that we're happy with. Now the model considers risks where it goes unnoticed by other models. The model starts with determining objectives and constraints of the software, starts with early iteration. Next phase is prototyping the software. This includes risks analysis. Once here, the SDLC model is used to build the software. The fourth phase of planning is iteration is prepared. So, the phase basically do all those, and repeat the cycle. After you finish all those, have a release. After release, if you want to repeat the cycle, you go through the next what's called next phase planning review. Then we continue with identification, cumulative cost progress, alternative evaluation, etc. All the way through the major steps. Risk management, prototypes, design, code, integration, test, and then implementation. As far as the V model is concerned, the major drawback of Waterfall Model, as we move to the next stage, we only use the next stage only when the previous one is finished. There was no choice for it to go back and something. Go back if something was found wrong. In later stages, the V model provides means of testing more software of each stage in a reverse manner. So let's look at this for a second. We get the requirements, system analysis. So we can go from requirements gathering to acceptance testing. acceptance testing back to requirements gathering. So we have the requirements we're gathering. We check to see if it's accepted. If it's accepted, then we have the testing of it, and then goes back to requirements. Make sure the testing fits the requirements. Then we start. Then we have system analysis. It goes to the system testing to make sure the testing to make sure it works. And the testing goes back to analysis to make sure it fits the requirement. Then with verification, we check the software design, the user module, and coding. Then goes to unit testing and integration testing, just like here. Requirements gathering, system analysis, system testing, and acceptance testing. So we can look at it this way, or it can look like it a V. Depends. It's basically going from left to right, right to left, left to right, right to left. Or we can look at it as requirement gathering, system analysis, system testing, acceptance testing, and back the same way. Basically, we're making two V's, basically. The thing to understand is two major things about verification and validation. We have software design, module design, and coding, and unit testing and integration testing. Remember that with software design, it goes to integration testing and back to software design. Because we're testing it back to, and we'll go back to its original design. Then we go to the module design and test it. We test the unit, it goes back to the design itself. Then we have the coding. Now, at every stage, test plans out and test cases are created to verify and validate the product according to requirements of the stage. So it makes complete sense. It's like if you create something, right? You have to make sure you have a requirement. Planning stage, you have requirements that needs to be tested. Once it's tested, you go back to design itself, make sure that it's valid. And then once it's been tested and it's good, then you can use the design. Once you have the design, then you need to use the module. What the module will do is say, okay, I need to test the module during unit testing. Unit testing then will return the results back to module testing. And of course, then finally, once you've done all of this, then we have the actual coding for the developers. You see this? Okay, that's why we have our manual QA first before we have developers. Because we've got to make sure all this works before we work on the coding. We also have something called the Big Bang model. The model is the simplest model of its form. It requires very little planning, lots of programming, and it requires very little planning, lots of programming, and lots of funds. The model is conceptual around the Big Bang of the universe. Scientists say that after the Big Bang, lots of galaxies, planets, stars evolved just as events. Likewise, if we put together lots of programming and funds, we achieve the best software in all time. So we take the major event, and it goes out to time, goes out to efforts, resources, and so on, as the diagram indicates. In this model, a very small amount of planning is required. That's the plus. It does not follow any process, or at times customers are not sure about any of the requirements and future needs. Input requirements are arbitrary, can change from time to time, and the model is not suitable for large software projects. A good one for learning and experimenting. That's what this is for. Now, I will do it for this actual software development lifecycle. So, hopefully you found that useful. It's definitely the core thing to consider because we have to have the right process and right thinking before we continue on with individual testing steps and other considerations. First thing we need to consider is the software development life cycle, or as they show here, SDLC. Alright, so I would like to thank you for watching this video as I know it added value to your life, especially if you're interested in software testing or the actual testing process behind coding. And so, please click like on the video as it will be pushed to the algorithm where people will be able to see it, enjoy it, and benefit from it, especially if you want to be a software tester. And you'll be able to see how I progress through so that way other people can be inspired and repeat the process I did as well. And it'll create opportunities for people. Please click the subscribe button, that way you'll have access to all my videos on this channel, as I do have a variety of content on this channel, which is uploaded to YouTube and Rumble. Also, if you haven't already, please click the bell button, that way you'll be notified of all my future videos. I would like to again thank you for watching this video. I'd like to wish you a great day wherever you are in the world. Take care, and I'll talk to you next time.